Hey y'all, this is Miss Morrison, and this is your Test 1 review for Business Calculus 2. Okay, so most of this test or review, we get to use tricks and formulas, and you have to remember to put them on your cheat sheet because you will not be given them. Okay, so it says find f prime x. If we have f parentheses x equals negative 8x to the fifth. Okay, to f prime means take the derivative, and we're going to use that thing called the power rule. Yeah. And the power rule says that if you have x to some number, to take the derivative of that, you take that number and you multiply it in front, then you subtract 1 from the exponent. Yeah, okay. So I'm going to take this 5 in the air and I'm going to multiply it with what's in front. And let's see, 5 times negative 8 is negative 40. So we're going to multiply that 5 times negative 8 and get negative 40. Then we're going to have x, and we subtract 1 from the exponent to the 4. So the derivative is negative 40x to the 4. Huzzah! Okay, again, this sucker says number 2, f parentheses t, what? Equals 6t to the 3 minus 5t plus 1. And it wants that weird f prime t thing again. That means derivative, and we're going to use this same rule over and over. So this 3 is going to come down in front and multiply with the 6, and 3 times 6 is 18. So again, you take your exponent and you multiply it with what's in front to get 18. Then you subtract 1 from the exponent. So 18t squared. All right. Then, if you're looking at this next sucker, his exponent is a pretend 1. So when you take that 1 and bring it down and multiply, 1 times negative 5 is negative 5. But then if I subtract 1 from that exponent, you get t to the 0. And we don't write t to the 0. It's the same thing as multiplying by 1. So when I subtract 1 from that exponent, I get 0 in the exponent, but anything to the 0 power is 1, so we don't have to write it. All right, and then this number 1, when I go to take the derivative of it, you can't. Yeah. Okay, so we have one rule already, a power rule. If you want to say something about this regular 1, you might call it the constant rule, which says the derivative of a number is not possible. Yeah. Or you might want to remember this, that when you have just a number on a letter with an exponent of 1, like if you have number x, the rule for that is that when you take the derivative of it, that letter to the 1 exponent disappears and you just get number. So there are 3 rules right there that can help you out. Okay, so the answer for this sucker is 18t squared minus 5. And when you go to type this stuff in your computer program, if you type it wrong, if you accidentally put some extra things in there, I'll give you partial credit. Okay, number 3, it says find y prime, but then they give us y equals 4x to the negative 5 plus 5x to the negative 1. Okay, we're going to use that same power rule where we take that negative 5, multiply it with what's in front, and bring it down. So negative 5 times 4 is negative 20. Then you write x, and you minus 1 from that exponent. Okay, this is tricky because when you minus 1, it does not give you negative 4. It gives you a bigger negative number. It makes negative 6. Okay, then we're going to take that negative 1 from the 5x, multiply it with the 5 in front, write it down, and we have minus 5x to the subtract 1 from the exponent. That does not make 0. When you subtract from a minus, you get an even bigger minus, so we get negative 2. And you can leave it just like this. If you accidentally converted it to this, that's cool. So you can type either or, but this first one is what will get you the correct answer right off the bat. If you type in this second sucker, I'll have to hand check it. But that's okay, I do that anyway. All right, number 4 says something about C parentheses X, and it gives you an equation. But then the directions are the marginal cost. And another word for marginal is find the derivative. Yeah, okay. Of whatever they told us. So they're talking about cost, so we're going to find the derivative of the cost. Well, the cost is that C of X, because cost starts with a C. Okay. All right, let's find the derivative of this. Well, this first sucker, 160, that's just a constant. The derivative of a number is not possible. So that scratches out, it goes away. All right. If I have a number X, the derivative is just the number attached to it. So this 5.5x just becomes 5.5. Or if you want to do it the old school way, you put a 1 in the air, you multiply the 1 times the 5.5, and you write 5.5. Then you minus 1 from the exponent, and we get x to the 0, and x to the 0 we don't write. Yeah. Okay, so that's why it's just 5.5. And then for this next piece, we take the 2 and multiply it with that number attached and bring it down. So 2 times negative, that is negative 0.08. X to the subtract 1 from the exponent. So we only have 1 in the air. Hey, this is our derivative. Or it's called the marginal cost. So every time you see the word marginal, it means take the derivative. Okay, let's go to number 5. Number 5, it gives you an equation for capital R, that means revenue, and then it asks for the marginal revenue. Remember, marginal means derivative. So let's take the derivative. This 3x, it has a 1 in the air, and we take the 1, we bring it down, multiply. 1 times 3 is 3. X to the subtract 1 from that exponent, but oh, that's x to the 0. And remember, x to the anything to the 0 you don't write. X to the 0 you don't write. Okay, so this is just 3. Okay, now let's find the derivative of this sucker. We're going to take the 2, bring it down and multiply. Oh, this is kind of redundant. Okay, and we get minus 0. I think it's 14 x, and then subtract 1 from the exponent. So 2 minus 1 is a big fat just 1. All right, that's the derivative. So every time you see marginal, take the derivative. Okay, number 6, it gives us capital C, which is the cost. It gives us capital R, which is the revenue. And it asks for the marginal profit. Okay, so marginal means derivative. Profit means something else, because I don't see no P on this problem. Okay, so Marginal means you're going to take the derivative. Yeah, okay. Profit, that's capital P. And to get profit, we take how much money you bring in, the revenue, minus the cost of operating the warehouse, the cost of electricity, all that. And that's how we get our profit. So this is an equation you need to write on your cheat sheet. If you don't have that equation and you don't remember it, how are you going to do the problem? All right, so profit is R of X, which is this 5X minus that thing. So let me write it down. 5X minus all right. Then I'm going to minus the C of X. But the C of X is a bunch of stuff. So to show that it's a bunch of stuff, I got to use a bunch of parentheses and put 186 plus 0.5X in there. All right. Now we're going to distribute the negative. And we get 5X minus, this part doesn't change, 0.02 squared. 0.02x squared minus 186 minus 0.5x. And the reason that 0.5 becomes a minus is because we distribute the negative. This is kind of like saying, my good friend, -1 multiply 0.5. So that's why it pops out negative. All right, then we're going to combine like terms. This 5x and 0.5x, those have the same back ends, the butts, they got an X. I cannot combine these with the squared because that's a different back end, that's a different butt. All right, so 5 minus 0.5 is something like 4.5 X, and then these others do not combine, so let me just write it. All right, so this is our profit, because we got it from this P of X equation. We did the revenue minus the cost. Now we have to derivatize it. We have to take the derivative, okay? Well, 4.5x to the 1, you take the 1, bring it down and multiply. You get 4.5x. To the 1 minus 1 is 0. Oh, daggone it. Remember, we don't write the x to the 0, ever. So this is just 4.5. Then the 2 on this x squared comes down and multiplies to minus 0.04. X to the subtract 1 from the air, you get a pretend 1 in the air. And then minus 186. Remember, that's called a constant. And if you take the derivative of just a naked number, it gets trashed. Because you can't take the derivative of a naked number. It just becomes 0. All right, so this is the marginal profit. You don't have to put that tiny 1 in the air, but if you do, it's not that big of a deal. All right, let's go to number 7. Number 7, it gives us the cost function. Then it gives us the revenue function. But then it says, what's the marginal average cost? Okay, this is a trap because they gave us too much information, hoping to trick us. Okay, when it says marginal, that means you have to take the derivative. We know that now, okay? Cost means that C of X formula. Average means you divide by X. Okay, nowhere did we mention revenue or profit, so this RX is useless information. We're not actually going to use it. Okay, so let's build our average cost, and then after we do that, we'll take the derivative. Okay, so the average cost is that cost equation, 122 plus 5.3x, but divided by x. That's what makes it the average, because when you average something, you count up how many of it there is, and then you divide by how many there were. So that's the dividing by x. So that's our average cost. Now we're going to take the derivative, and there's a couple of different ways we could do this. We could use the quotient rule, or we could use negative exponents and the power rule. Let's try the negative exponents first. Okay. This is the same thing as saying 122 over x plus sign 5.3x over x. See how I separated it? Both of these tops are on top of this x. So I just rewrote both separated on top of an x. Okay. This 122x to the 1, that's like saying 122x to the negative 1. When you pull something out from below, or when you take something from underneath the denominator and bring it up big and fat and normal, you take whatever exponent it had, 1, and make it negative. Okay, then this second piece, the x's cancel out, and you just have plus 5.3. All right, now we do our little power rule. The power rule says you take that negative 1, you multiply it in front, okay, and you get 122 times negative 1. It's negative 122. X to the, subtract 1 from the exponent. Negative 1 minus 1 is not 0. It's negative 2. All right, and then plus 5.3, well, that's that constant, where if you have a number and you take the derivative of it, it just gets crossed out. All right, so this is our marginal average cost, or you could write it as negative 122 and throw that x squared back underneath where it came from. And when you throw it underneath, the exponent becomes positive. Okay, that's the power rule. That's my favorite. If you want to use the quotient, I'll do it. Okay, the quotient is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, this isn't quite the formula, but I just used words instead. Okay, so the bottom is x times the derivative of the top. The derivative of a naked number, 122, just gets thrown out. The derivative of 5.3x is just 5.3. It's kind of like that number x rule we talked about, where if you have a number x, it just goes to a number. Okay, let's keep going. Minus the top, which is 122 plus 5.3x, times the derivative of the bottom. The derivative of the bottom, well, let's see. There's a pretend 1 in the air. Oh, this is just 1x. Okay. Well, the number x rule says if you have number x, the derivative is just that number. Or 1x, the derivative is just 1. All over the bottom squared. Okay, hopefully you can see that this is going to be too much for you to do. So, if I were you, I would focus on changing that x from the denominator, from the bottom, into a negative exponent and using this power rule. Because we still have, oh my goodness, so much more to go. We have to distribute the negative, we have to combine like terms, we have to come up with a GCF, then we have to cancel with the bottom. So it's like 5 more minutes if we were to do this quotient. So don't do the quotient on this problem. It'll take you too long and you'll probably mess up. No offense. Okay, so our answer is just this negative 122 x to the negative 2, or you can put it as a fat fraction with that x2 being positive. All right, let's go to number 8. Okay, it says, recently a certain bank offered a 10-year CD. That's our time, T. that earns a 2.17% compounded continuously. Okay, R, that's the interest rate, that's 2.17%, but we have to change this from a percentage to not a percentage. So we're going to take this decimale and move it twice to the left. I know that feels weird, but it's too bad. And when we move it to the left, you get a big fat 0 thrown in that little empty hump right there. Okay, so this becomes 0.0217. And that's my new R. All right. Then it says compounded continuously means you use that formula. Capital A equals capital P little e exponent RT. Yeah. Okay. Part A says if $10,000 is invested, and that's the capital P, that's what we put in. That's how I remember what capital P is. It's what you put into the account. And this is a CD. CD does not mean like those things you listen to in the car. It means an account that earns interest, like at the bank. Okay. Anyway, so P is what you put in. And it says, how much will it be worth in 10 years? Okay. How much will it be worth? Is the capital A. It's the accumulated value. We don't know it yet, but they're asking how much that will be in 10 years. Okay, so let's use our formula. We're going to have capital A, capital P, little e, exponent RT. All right? So capital A, we don't know. We don't know it. Capital P is 10,000. Don't type a comma. Little e, to get the little e, you have to press second LN. And that's because above the LN, there's a little blue E. So you have to press second and then LN to get that E. Or you might could have pressed second and this, where's it at? This division symbol. See how there's a little E? Yeah, okay. So second LN, and that'll pop up an E. And then you'll say RT, 0.0217 times the T, which is 10. Okay, so if I were to plug this in and not use the buttons, it would look like A equals 10,000 E exponent 0.0217 times 10. Yeah. Okay, but if I'm using my calculator, and remember, if you don't have a calculator, borrow one from the testing center, or find a math teacher on your campus and ask them to help you find one to borrow. There should be ones to borrow. If you're at home, you're just using your calculator app. I don't think you can really do this in your iPhone app, just your regular calculator in your iPhone. You have to use it on your special Text Instruments app. So 10,000, second LN, then 0.0217 times 10. And we should get 12423.441. And the next part is the part that people get wrong all the time. Okay, when we write down money, we only write down 2 spots after the decimal. That's how money works. When we go to the register, we don't see 3 spots. So this 1 in the 3rd spot is 4 or less. So that means we're going to let this 44 rest. We're not going to bump it up to 45. Okay? So this number 1 is 4 or less. So we're going to let this 44 rest. So it's 12423.44. And that's how much money we had at the end of 10 years. All right. Now it says part B, how long will it take Ooh, okay. And how long means the letter T for time. How long will it take, time, for it to be worth 25,000? All right. Well, let's see here. We have capital A equals capital P E to the R-T. Okay. How much it's worth in the end is the capital A. So this 25,000 is the capital A. It's how much it's worth in the end. The money we put in is still that $10,000. It did not say anything otherwise. The E is just a symbol. The R is still that where's it at? Up here, 0.0217. Only we don't know the T. Uh-oh. Okay, there's two ways to do this. We can use a calculator trick. Oops, calculator trick. Or we can use our hand, like paper pencil. Okay, let's learn about the calculator trick. For the calculator trick, we can plug the right side of this equation into y equals, so 10,000 second ln to get the e to pop up, and then 0.0217, and then the xt theta button. Okay, let me show you what to do. We're going to press y equals, it's at the top left. Okay, let's type in my goodies. I got to clear out some stuff. Okay, let's go. 10,000. Second ln to get the e, then 0.0217, and then to get the letter, to get that extra letter up in the air, we're going to press this xt theta button. It's right by the green. Okay, yeah. Then we're going to go to our graph. So press graph at the top right. And we probably can't see anything. Yeah, okay. So then we press second graph to get to our table. Hello. Okay, there we go. Second graph. There we go. So y equals, type in your goodies, and then if you want to skip the whole looking at the picture, you can. You can just press second graph. And then you are going to be looking for what number on the left gets you closest to whatever we're supposed to end up with, 25,000. And so you would start scrolling down, and we're looking for 25,000 in this blue. And I think the closest thing to 25,000 is maybe this 43. So our chart says 42 and 43, and the 42 is 24 and something like that. The 40 crap. The 42 is 24,878. The 43 is 25,424. So the question is, when do we hit 25,000? Well, 25,000 happens somewhere in between here. Okay, so it's going to happen somewhere in between 42 and 43. So you can say x equals 42-ish, but that won't get you all the credit. It's how you can kind of check your answer, or if you're desperate and you have no idea what I'm about to do by hand, you can use this little trick. Okay, so this trick doesn't give you the exactly perfect answer, but if we don't want to do this handwork, then we can use the trick to get partial credit, almost all credit. Okay. If I want to do it by hand, I gotta solve for the letter T. That means get the T by itself. Well, to get to the T, I got to start down here and build up to the T. So first, this 10,000 is multiplied with the E. If I want to get that letter T by itself, let me get rid of this 10,000. So I'm going to divide both sides by 10,000. And 25,000 divided by 10,000 is 2.5. Then these 10,000s cancel, and you get e to the 0.0217 t. Okay. Then to get the letter T by itself, you put a LN on both sides. And when you do that, it cancels out the E. What? So we get LN 2.5 equals 0.0217 T. So when you put the LN on a letter E, they cancel out. It's like they're opposites, they're inverses. Okay, then to get the T by itself, I see that this crazy decimal is multiplying. So the opposite of multiplying is to divide. Okay, and then we put this in our calculator. And to get the LN, it's just the regular LN button. Then we type 2.5. We might have to close our parentheses, then divided by 0.021. Crap, that was supposed to be a 7. Darn. My bad. I meant to say darn. Darn. Okay, so we're going to say LN in our calculator. LN 2.5. And you might have to close a parentheses, like I need to close my parentheses. It depends on what your calculator pops up. Then divided by 0.0217. And we get or T or X, whoever, equals 42 point. It says round to 2 decimal places. So that second 2, we look to the right of it, and I see a 5, and 5 or more up the score. So I'm going to take this 0.22 and make it 0.23. Yeah. Okay. So again, you can use either one, but by hand, the handwork will give you the perfect, exact answer, and you'll get all the credit. If you use this calculator trick, it'll get you close to full credit. Not as much, but close enough. Okay, so you can survive that one. Let's look at number 9. Number 9 says, at what nominal rate, what the poop? So that means the rate, that's the interest rate, that's the percentage. Something, something, something compounded continuously. That means that capital A equals capital E, capital A equals capital P, little e, exponent RT. Then it says, must money be invested to triple? Okay, triple. If I want something to triple, that means multiply by 3. And then it says something about the time is 6 years. Okay, so this is the same equation we were just working with, only the numbers they give us are kind of different. Okay, so we have capital A equals capital P or T. Good, okay. And my T is 6, for sure. But what? We don't know anything else. Okay, well, when it says we want to triple our money in 3 years, that means the P that we start with when it ends We're not going to end. So the money that we put in, that we start with, gets multiplied by 3. It gets tripled. So this is saying that the money we put in will triple. Okay, so the money we started with, they didn't tell us anything. They didn't tell us how much we started with. But I know that it's the letter P. They did not tell us how much money we ended with. But I know it's triple. It's 3 times what I started with. Okay, if it would have said quadrupled, I would say 4 multiply dot. If it would have said doubled, I would have said 2 multiply dot. Okay. So I start with P, I end with 3P. Okay, since this is the thing I end with, that's the same thing as capital A, because A means what you've accumulated or what we end with. Okay, so let's see if we can do this. We're not going to have an A anymore. Instead, we're going to say 3P. That means triple what you put in. Equals what you put in, which is capital P, we don't know what it is, E, the R we don't know, but we do know our T is times 6 years. Okay, this seems like there's too many different letters to be able to solve, but we can do it. Okay, if I want to get this R by itself, I have to start down here on level ground, kind of like we did on this last example. We divided by 10,000. Yep, okay, same thing here. Instead of dividing by 10,000, here we have a P. A P. Okay, and the opposite of multiplying P is divide P. Okay, well, the P's cancel. Left and right. And all we get is big fat 3 equals little bitty e r parentheses 6. Okay. And then it turns out like number 8b. You put an L in on both sides. The L-in and the E cancel. Okay, let's go. We put an L in on both sides. The L-in and the E cancel. So all we have is Ln3 equals R times 6. Okay, how do we get rid of the R? How do we get R by itself? Well, right now it's multiplying by 6. That's what parentheses mean, multiply. So the opposite of multiply by 6 is divide by 6. And in your calculator, you're going to type Ln 3, and then you have to close your parentheses, then divide 6. This is not Ln of 1/2 or whatever you're thinking. It doesn't work that way. Make sure you close your parentheses and then divide by 6. And we get 0.183 equals your R. But in your little answer box, it says blah, 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 and then right after the answer box, it says percentage. So we cannot type this 0.183 in because it's not the percentage. We have to move our decimal. Remember on number 8 when they gave us a percentage and then we moved the decimal twice to the left? It's like we're doing it bass-ackwards. So we're given the decimal and we want to come up with the percent, so move your decimal twice to the right. You might want to write that on your cheat sheet. Yeah. Okay, and twice to the right will pop out 18.3%. And that's the nominal rate. All right, let's go to number 10. Okay, for number 10, it has that nice e to the x. And if you remember the e to the x, the derivative is kind of lame. Yeah. So let's maybe make a e to the x rule. When you have e to the x, the derivative is just the exact same thing, e to the x. Okay. If you have like a number e to the x. The derivative is the exact same thing. Number, e to the x. Okay. If you have e to the x and other stuff up there, okay, then the derivative is you have to use the chain rule. Yeah, okay. So here's 3 rules for e to the x. If you have just regular e to the x, the derivative pops out the same thing. Number e to the x pops out the same thing. E to the x with a bunch of stuff in the air, you have to do the chain rule. Yeah, so we just have a regular x in the air, so we don't have to do that funky chain rule. All right, let's go. The derivative of this negative 8 gets canceled out because it's a constant. The derivative of negative 2x just becomes negative 2. Then the derivative of 4e to the x is just the exact same thing, 4e to the x. Heyo, done. Number 11. Whoops, I'm kind of all over the place. Okay, so for number 11, we have this awkward looking LN looking thing. Yeah, okay. The LN rule, oh gosh, let's see here. The LN rule is if you have LN of x, it becomes 1 over x. If you have LN of, let's say, stuff with x, so we have just x, so we're going to use this first rule. Yeah, okay. But if I have ln and then a bunch of stuff with my x, like x squared minus 18 or something, all up on this ln, then you do 1 over the stuff times the derivative of the stuff. Okay? If you have number ln x, the derivative of it is just the number over x. So there's 3 rules for ln. All right, let's see what we got. We have negative 8 ln x. That's not this first or the second because the number's in front of the ln. So negative 8 ln x just goes to 8 over x, but it's negative. Don't forget, because that negative was on the 8. Okay, then for the 9x squared, we use the power rule, where we take the 2, bring it down in front, multiply it with the 9, write it down. 2 times 9 is +18. 18. X to the subtract 1 from the exponent. So we just have a 1 in the air. Okay, and then constants get canceled out. So my derivative is this sucker. And on your test, if it counts you wrong, I'll go back and hand grade it, eyeball it. So, if you get really close, but you just wrote the wrong symbol, that's cool. You'll get partial credit. All right, so let's look at this sucker. We have to find the derivative, and it says ln x to the 5th plus 7 ln x. Okay, well, this 7 ln x is this last rule that says number ln x goes to number over x. So we just have, this becomes 7 over x, and it's a plusative because there was a plusative. Okay, if we have ln with a bunch of stuff with x, which I do because it has that 5 in the air, then I take 1 over the stuff. Okay, let's see here. 1 over the stuff of x to the 5th. Oh, poop. Hold on. I can do this again. 1 over the stuff of x to the 5th times the derivative of the stuff. Okay, what's the derivative of x to the 5? Well, you take the exponent, you bring it down in front, you multiply it, and then you subtract 1 from the exponent. Okay, so 5, bring it down in front, makes 5x. Subtract 1 from the exponent, makes 4. Okay, and then something awesome happens. When you multiply fractions, you multiply Lizzo left to right. And we get 5x to the 4th over x to the 5th. Okay, then we still have plus this big fat 7 over x. All right. This x to the 4 really means 4 x's smashed up on each other multiplying. X to the 5 means 5 x's smashed up on each other multiplying. You can cancel. Pair from one from the top, one from the bottom, one from the top, one from the bottom, one from the top, one from the top, one from the... Or you can say, hey, all of those x's from the top are going to cancel out, go away. And the ones from the bottom, there's not going to be 5 left over. There's just going to be 1. So cross out that 5 in the air and put a 1. So this becomes 5 over x to the, we don't really have to put the 1, plus 7 over x. And now when you add fractions, you add the tops, but you don't touch the bottom. Yeah, okay. So if I add the 5 and the 7, I get 12. And then don't touch the bottom x. Hey, that's the derivative for number 12. All right, let's go to 13. All right, it says find the equation of the tangent line to the graph of f at the indicated value of x. Okay, the equation of the tangent line, that hoopla is y minus y1 equals m parentheses x minus x1. Yeah. Okay. Well, first, let's take the derivative. Because this m is the derivative after you plugged in whatever your x equals a number. So this m will be the derivative. So let's go ahead and find the derivative. Okay, the derivative of this 8 is a constant, so it goes away to just 0. The derivative of ln x is 1 over x. So this is the derivative. It's also the slope. After, and slope is the letter m, after you plugged in whatever x value they gave us. So they gave us 1. So I'm going to take this 1 that they gave us and plug it in where the x is. Okay, so instead of 1 over x, we have 1 over 1. And heck fire, that gives you 1 when you divide it. All right, so we have the m. Yay. Okay. This x1 they gave us. Yeah. This x1 is the x value they gave us. Okay. The y1, we're going to have to find that by plugging in x equals a number into the original. Yeah. Okay, so this m, we plugged in x equals a number into the derivative. This y1, we plug in x equals a number into what we started with. Like this f parentheses x hoopla. Okay, so let's plug in this 1 into this f parentheses x hoopla, not the derivative. Okay, if I plug in 1 to this x, and I'm plugging in 1 because that's what they gave us, x equals 1. So if I plug in 1 to these x's, let's see what we get. We're going to put this in the calculator. We're going to say 8 plus the ln button then 1. 8 plus the LN button, 1. And the LN button is over here by the 4. And I can always tell who, use Photomath for all of their homework, because on the test, people write IN or 1N instead of LN. So that's how I know if they cheated on all their homeworks. Okay, so let's put this in our calculator. 8 plus LN is 8. All right, this is our y1. All right, so our very first step was to take the derivative, and we got 1 over x. My second step was to plug in that x equals 1 into the denominator. My third step was to figure out our y1. And now my fourth step is to plug it all in. And when I say plug it in, I mean plug it into these 3 spots, the x1, y1, and the m. Okay, the m came from the derivative. And plugging in 1, it was 1. Okay, the x1 they gave us, it was 1. This y1, we put our calculator, we did our calculatore, okay, and we put a 1 in for the x value, and then we typed in 8 plus ln1. And we got 8. All right, let's plug the goods in. We're going to have y minus 8 equals a slope of 1 parentheses x minus 1. All right, and then technically I'm good with this. If you want to stop right there, your test might count it wrong, but then I'll go back and by hand give it to you right. Okay, if you want to keep going, you can turn it into y equals mx plus b by saying y minus 8 equals this 1 multiplied in, doesn't do anything, so we just have x minus 1. And then to finish it and get y equals plus 8, and we get y equals x plus 7. Yeah. Okay, and again, I'm okay with either or of these 2 equations. Your test might count one or the other wrong, but then I'll go back and count it right by hand. Okay, let's go to 14. All right, we have y equals 2 log 5x, where 5 is the basement or the subscript. And when we have log and a little number in the subscript or the basement, when I take the derivative of this, it turns into 1 over x ln of that number. So this is a log rule. I didn't quite write it super fancy, but I think you'll like it. Okay. If we have something else in front of this log, like this 2, I'll just put like a little heart. Okay, whatever. So if we have a number in front of that log, it goes on whoa, it goes on the top, and then the bottom we have x ln of that number that was in the subscript. Okay, so for us, we have number log x, so we're going to use this second rule that says it pops out the number that was to the left of the L, 2, over x ln, the number that came from the subscript, 5. Hey, yeah. Okay, let's go to 15. 15 talks about an exponential rule for if x is in the air. Okay, if you have a number to the x power, when you take the derivative of that, it pops out the exact same thing, number to the x, but then you slap a ln of that number on it. Okay, so for 7 to the x, the trick is, or the formula, or the rule is, it pops out 7 to the x, right back at me, and then ln of the number, which is 7. Hey, and that one's kind of funky to type, so if you have all the right symbols there, but maybe they're all hanging out in the air because you forgot to arrow down or something, I'll give you partial credit. Okay. All right, 16. There's 2 ways we could do 16. We could do the product rule. Let's go ahead and say the product rule. The product rule is the first times the derivative of the second plus the second times the derivative of the first. Okay, so let's try that. When I say first and second, I mean this 9x to the 3 is the first, and x squared minus 2 is the second. Yeah, okay. All right, let's roll. First, that's the exact same thing that we already have written down, 9x to the 3. Derivative of the second, you take that 2, bring it down in front, and you get 2x, then you subtract 1 from the exponent, and it makes a 1 exponent, and I don't even have to write that down, okay? Then the 2, when you take the derivative of a 2, it becomes nothing. Yeah, okay. So close your parentheses, plus the second term, x squared minus 2. So you write it exactly like it is, times the derivative of the first. So bring the exponent down in front and multiply, and we get 27x squared. Okay, and then multiply. 9 times 2 is 18. X to the 3 times x to the 1 is you add the tiny numbers, or the exponents, and you get 4. Okay, then for this next piece, we got to distribute. It's kind of awkward distributing. We're going to have plus sign 27x to the, add the tinies, which makes 4. Then negative 2 times 27x squared is negative 54x squared. Right? All right, and then I combine these first 2 terms because they have the same butts. So 18 plus 27, oh my goodness. 30. I think it's 45, but you don't change the exponents. X to the 4 minus 54x squared. Hey, that's the derivative. If you use the product rule. Okay, if you just multiply it out, then use the power rule, it might be a little bit easier for you. So you get to choose what you want to do. If I multiply this out, let's not forget that when you multiply, you add the tiny exponents. All right, so we get 9 times 9. X to the 3 plus 2 is 5. Okay, then 9x to the 3 times negative 2 is, multiply the big numbers. 9 times negative 2, negative 18. Tack on the letters. X to the 3. Okay, and you might be thinking, wait, that's not the answer. Well, because we have to use the power rule. So this was our first step. We multiplied it out. Now we use the power rule. You take that 5, bring it down, and multiply it with the, what? New way? I don't know. Okay, and then 9 times 5 is what? 40? X to the, subtract 1 from the exponent. 4. 9 times 5 is 45. What a bum. Okay, 45, x to the 4. And then, let's see, take this 3, bring it, and multiply it down in front. Oh, gosh. I think it's 48. Nope, it's 54. Don't listen to me. Okay, minus 54, x to the, subtract 1 from the exponent, 2. And hey, oh, look, we came up with the same answer. So whatever you're more comfortable with, you can use. It doesn't matter. Both will give you the same thing. Okay, let's look at 17. It's the same-ish. We could use the product rule and waste our life away. Or we could try and FOIL and then use the power rule. So we could try and use the product rule. And if we use the product rule, 6x plus 8 is the first, and 3x minus 2 is the second. And then let me pull up the product rule from that last problem we did so I don't have to rewrite it again. Here it is right here, okay. The product rule. It says first, okay, 6x plus 8, put it in parentheses, times the derivative of the second, okay, 3x minus 2, the 2 gets scratched out, 3x just goes to 3. Plus sign, the second, 3x minus 2. Times the derivative of the first. The derivative of 6x plus 8. The 8 goes away because it's a constant. Cancels out. The 6x just goes to a 6. Alright. And then multiply. Distribute. So that 3 has to go to both. So we get 18x plus 24. Then on this second piece, the 6 gets distributed backwards. So 6 times 3x is another 18x. And 6 times negative 2 is minus 12. Combine like terms, because they have the same butts. And then I think I'll do this 24 and this minus 12. So we get 36x plus 12. Hey-oh, that's the derivative. Okay, if you want to FOIL it out, like multiply it out, then use the power rule, we can do that too. Okay, let's FOIL this beast out. F means 6x times 3x. That's 18x squared. Okay, O means 6x times negative 2. It's the stuff on the outsides. And that makes negative 12x. Alright, then we have innards. 8 and this 3x. And we're multiplying. And you get a 24x. I just put a plusative to help me out later on. And then the L is 8 times negative 2. And that makes minus 16. Okay, let's write down what I got. I got 18x squared minus 12x plus 24x minus 16. So when we write down what I got, I don't write down what's to the left of these equal signs. I was just writing those down to tell you what I was multiplying. We write down what's to the right of the equal sign, the 18x squared. Brrr, okay. All right, let's combine like terms. I'm okay. I panicked. All right, and we combine like terms, and you get the 18x squared does not change. The minus 16 does not change. The like terms, those become plusative 12x, because negative 12 plus 24 is 12x. Okay, now we use the power rule, which says take the 2 in there, bring it down in front, and multiply 2 times 18 is 36. X to the subtract 1 from the exponent. Wait, okay. Then that 12x, remember a number x just goes to that number. And then the 16 gets knocked out. So hey, we get the same answer. It's just whatever your preference is. All right, let's go to 18. 18, we don't get to do a preference. We have to do the horrible. Okay, 18, it says difference quotient. All right. Or no, 18, it says find f prime of x. That's the derivative. Okay, so the difference quotient is, I think I wrote it somewhere. Here it is. Yeah. Okay. All right. It says the bottom. Okay, so let me write down the bottom. 5x plus 4. The reason we have to do the horrible on this sucker is because we're dividing by 5x plus 4. Before, we didn't have to do the quotient. It's because we were dividing by just like a little x, like just one x. So we could use that whole negative exponent hoopla, but we can't do that when we're dividing by 5 of them x's plus 4. Okay. All right, so we're going to have the bottom times the derivative of the top. Okay, the top is 2x minus 1, and when you take the derivative of that, 2x goes to a 2, and negative 1 just gets scratched out. Okay, let's keep going. Minus the top, which is 2x minus 1, times the derivative of the bottom, 5x plus 4. The derivative is just 5 because the 4 cancels out. All over the bottom squared. Okay, the way you're going to get, if you get this wrong, it will be because of this area in the top right. Something will happen over here that we do wrong. Okay, so first let's start distributizing. It's weird because it's bass-ackwards. So 2 times 5x and 2 times 4. Or 5x times 2 is 10x. 4 times 2 is plus 8. All right, and then let's see what happens here. I'm going to have, if I distribute this bass-ackwards, this becomes 2x times 5. 10x, negative 1 times 5, minus 5. But then, this negative hits both of those and distributes again. What? So we do 2x times 5, negative 1 times 5, and we get this. But then we have to multiply by a negative. And when we multiply by a negative, the symbols change. So this 10x is now negative 10x. Or this negative 5 is now plusative 5. Okay, if you didn't like that way, think of it this way. You take the negative and you multiply it with 2x and then multiply it with a 5. And that's how we get negative 10x. Then you take that same negative and multiply it with the negative 1 and the 5. And that's how we get plusative 5. So either way, you have to multiply 2x and the minus 1 with the 5, and then you have to multiply both of that with a negative, and it changes the symbols. All over this bottom squared. All right, from here, we can see that like terms, the 10x is canceled, and then 8 plus 5 is 13. Yeah. And your test, some of it will be multiple choice, but the majority of it will be typing in. So if you literally have no idea what you're doing, you're going to get no credit. Okay. All right, let's go to 19. It says f parentheses x equals 4x5 ln x. Okay, and it says find the derivative. This, I see two different things like smashed up on each other. That means it's a pretend multiply, and this is the product rule. It's the product rule because I have two things being multiplied. Yeah. Okay, let's just real quick find the derivatives of just singles. So like this 4x to the 5. What's the derivative of that? The 5 comes down in front and makes 20. Subtract 1 from the exponent, get a 4. Okay, what's the derivative of this ln x? Well, we went over that. It's 1 over x. All right, now that we figure out the derivatives, let's use that product rule. It says first times the derivative of the second. Okay, let's go. First, 4x to the 5th times the derivative of the second. Well, second is ln x. The derivative was 1 over x. Okay, got it. Plus sign the second ln x times the derivative of the first. The derivative of the first 4x to the 5th, the derivative was 20x to the 4th. All right. Now we're going to say this 4x to the 5th is over 1. And then we're going to multiply left to right. This makes 4x to the 5th over x. And then we've talked about this. X to the 5th means there's 5 x's up on there. X on the bottom just means there's one of them. Okay? You can cross out a pair, but there's still quattro left over. There's four left. Okay, so we still have big fat 4. We still have the little x, but then the x on the bottom crossed out all the way. And that 5 on the top, there's no longer 5 x's on the top. There's just 1, 2, 3, quattro. There's just 4. So the derivative is 4x to the 4, okay? But then over here on the right, when we multiply these two suckers together, all we do is smash the ln on the right. So we say plus sign 20x to the 4th ln x. Yeah. All right. And if you accidentally type some of that in wrong, but you'll get partial credit. Don't worry. All right. Let's say for the next sucker, number 20, we have f parentheses x equals parentheses 3 minus 7x to the 9 exponent. Okay. This is the chain rule. The way you know when to use the chain of fools. Okay, you know you're going to use the chain if you have a bunch of x stuff to a number, or you have a e to a bunch of x stuff, or you have, what is it, like square root of x stuff. Yeah, okay, we'll talk about it later. Okay, anyway, so basically if you have a bunch of junk happening raised to an exponent, we got to use the chain rule. Okay, the chain rule says you take if you have stuff inside to a number, the derivative of it is you put the number in front, like normal. You repeat the same stuff. You minus 1 in the air from the exponent, and then you multiply by the derivative of the stuff. Okay, I didn't quite use the symbols, but this might help you better. All right, so let's find this derivative. We're going to take that 9 and put it down in front. We're going to rewrite the same stuff from inside the parentheses. We're going to subtract 1 from the exponent. 9 minus 1 is 8. Then we're going to multiply by the derivative of the stuff. Okay, let's see here. Okay, the derivative of that 3 is nothing. Nope. The derivative of the negative 7x is negative 7. So we have to multiply this by negative 7. And then very lastly, you're going to take that naked number from the very left and that naked number from the very right and multiply them together. 9 times 63, but it's negative. And then to the right of that negative 63, write down that exact same parentheses with the exponent 8. Hey, that's the derivative. Let's try 21. 21 says f parentheses x equals e to the 2x. Okay. Okay, for this, since we have an e, it's a little bit more awkward, but it's okay. I'm going to tell you what to do. First, okay, the derivative of an e to the something is e to the same stuff times the derivative of the stuff. Yeah. So the derivative of e to the x is the exact same e to the 2x, the exact same stuff, times the derivative of what's in that air. Okay, what's the derivative of 2x? It just goes to 2. All right, and then we're going to multiply my pretend good friend Juan from the very left of the e. We're going to multiply that 1 and 2 and make 2 e to the 2x. Hey-o, that's your derivative. Okay, let's go to 22. Same rule we just did, only if we have a number in front, we keep that number in front of our e. Okay, so I have a number in front. So I'm going to keep it exactly the same, 9. E to the same stuff, negative 5x, times the derivative of that negative 5x. The derivative of negative 5x just goes to negative 5, because if you subtract 1 from the exponent, you get a 0, and then you don't write that x. So anyway, this is times negative 5. And then we're going to do that same front and back thing we've done on the last 2 problems and multiply 9 times negative 5. It's negative 45. And smash up that e hoopla. Yeah. And again, on your test, if you type slightly the wrong thing, you're going to get partial credit. All right, 23. It says parentheses 7 plus L in x, close parentheses to the 3. All right, so let's see here. We're going to take the 3, bring it down in front. 3. Then write down the exact same stuff. 7 plus L in x. Subtract 1 from the exponent. That makes a 2. Then multiply by the derivative of what's inside. Okay, if we're doing the derivatives of what's inside, that 7 is a constant. You can't take the derivative of it. It goes away. The L in x goes to 1 over x. All right. Okay. And then, just like the last 3 problems, we're going to take this 3 and this 1x and multiply them. Okay, let's see if we can do this. 3 times 1 over x. Okay, that 3 has my good friend 1 underneath. Okay, and when you multiply that, you get 3 on top, x on bottom. Okay, so my answer is going to have 3 on top, x on bottom. Yeah. And then the rest of this hoopla with the parentheses, it's just going to go on top. So this stuff with the parentheses gets thrown on the top. The 3 stays on the top, but it's the x that goes to the bottom. Yeah, and it's all supposed to be squished up. So 3 parentheses 7 plus ln x squared over x. Mine's just kind of spacey. All right, let's keep going. Oh, that's it. I guess. All right, so for your cheat sheet, I would make sure and write down all of these cutesy little formulas or the actual formulas, whichever one you prefer. And I would show all the work on your cheat sheet because most of the test is where you have to type in your answers. If it was multiple choice, we'd be able to pick the correct answer pretty easily just through process of elimination. But when you're typing in the answer, it's more rough. Okay, so remember, you can have 1 page, front and back, of whatever you want. I would write down every problem from the review. I would write down every formula. I would write down any calculator steps, anything, any special notes to yourself, anything. Okay. Have a great day. Good luck this week. Don't forget that if you have not taken your first test, the deadline is this week and this Friday. And then your second test, the deadline is also this Friday.